Hey everyone, welcome back to my channel. In this tutorial, I'm going to demonstrate how to produce results from two sample t-test in Stata. In order to do so, I'm going to use a variable called BP systole, which is systolic blood pressure, and another variable called female, which is basically representing sex, where female is coded as 1 and male coded as 0, making it a binary variable or categorical variable, right? So our interest is to understand uh, whether females' average blood pressure, systolic blood pressure, is significantly different than the male's average or mean systolic blood pressure. Okay, so the purpose of two sample t-test is to compare two independent groups average, okay, in terms of any outcome. In our case, this is systolic blood pressure. So you need, on the one hand, you need a continuous variable like systolic blood pressure and a binary variable like female in our case. So let's know about our data first. So first I will use a summarize command, sum and BP systole, and see that BP systole, which is systolic blood pressure, in our data set 10,351 observations, all of these people have on average 130 or 131, basically 131 systolic blood pressure, right? Another variable we're going to tabulate it is a female, which is the binary variable, right? Which has two categories, male and female, right? So our interest is to know the average of the male and average of the female systolic blood pressure, right? Overall, it is 130, but we do not know what is the average systolic blood pressure for male and what is the average systolic blood pressure for female, and whether their average blood pressure for these two different groups are statistically different or significantly different, right? So that's what we are trying to understand. So that is the purpose of two sample t-test. So they're independent groups, male and female, and their outcome of like mean outcome for both the groups is different or not. So to do that, we're gonna write a code called t-test and BP systole, comma, by, so that would be categorical variable female. Okay, so now hit enter. I think BP systole, BP systole is misspelled. Hit enter. Yes, now you can see in this table male and female, two different groups. This is two sample t-tests, and then these two sample and independent groups, right? We have seen before that the average overall is 130, right? Combined male and female. But for male, the average systolic blood pressure is 132 or 133 almost. And for female, the average blood pressure, systolic blood pressure, is 129. So we can see some difference, right? However, we do not yet know whether this difference, which is 3.81 or 82 almost, 3.82, whether this number, this difference, is statistically significant or not. So interestingly, p-value gives us this number, which is p-value, right? The probability value. And we know that any value that is less than 0.05, any p-value, that is considered statistically significant. So in our case, we can see this is the two-tailed test, and there's no direction in it because you can see this absolute value symbol, this bar in both sides of the t, in both sides of the small t. So that means there is no direction, positive or negative, right? So that's what makes a two-tailed test, meaning that we are not specifying any direction towards negative or positive. So here there's a positive direction, this is the negative direction, but there's no, this is two-tailed test, which is the best practice model to produce the two-test tail. That makes more sense, right? So we are interested in understanding whether they are different or not, and we're not interested in which direction, right? Negative or positive, whether the difference is negative or positive, right? So and of course positive, and that's why you can see this positive is significant and negative is not significant, because it's the this number is 3.81. It's positive number. Okay. Okay, so now the thing is, you can pretty much clear, you can be pretty much clear that this number probability value or p value is less than 0.05. So this is highly significant. Even it is even less than 0.001. So that's what makes it statistically significant. So now we know that the mean difference for females' blood pressure and males' blood pressure, which is 3.81, is statistically significant. So that's all about uh, two sample t-test. Okay. And I hope you like this video. And if you find my videos helpful, please subscribe my channel, like, comment, and share. And also, if you have questions, feel free to ask. And I'll be happy to answer any questions that you may have. Thanks for watching.